If you are starting the organic chemistry and you want to study about the reaction intermediates like carbonium ions, carbon ions, carbines, etc., want to study their structure, formation, stability, reactions, etc. in a clearer manner, then this is the videos that is being made for you. This is the right place where you should watch the videos. Okay. Hi students, I am Priyanka Jain and you are watching the videos of reaction intermediates and carbanions. This video is especially for the carbanions, and one thing I want to tell you that we have soon launched our app and where the courses, complete courses of the inorganic chemistry and physical chemistry etc. are available. So you can watch these courses. These courses are available with free PDFs and test series. Okay, so if you want, you can watch these courses and you can purchase them. Okay, now we are starting the carbanions. Actually, carbanions are the anions. Means these are the negatively charged species in which the carbon carries three bonds and a lone pair of electron. So this lone pair of electron is making the carbon negatively charged. We know that in the carbon there should be four bonds, but there are three bonds and there is a negative charge. This negative charge means there is a lone pair of electron present. Okay, so how this lone pair will look like? See here. Actually, the central carbon atom is sp3 hybridized with three bonding pairs of electrons and a lone pair of electrons. You know, whenever you make sp3 hybridization means a tetrahedral geometry. This means tetrahedral geometry because in the sp3 hybridization there should be four bonds, but actually there are three bonds. Okay, means to say there is a lone pair of electron with three bond pairs of electron. So this type of geometry you have seen will have a pyramidal geometry. Okay, this is called pyramidal shape. This is you have seen in the case of NH3. When we have studied NH3 in the inorganic chemistry, you have seen that this will be in this manner. Three bonding pairs of electron and one sp3 hybridized orbital contains a lone pair of electron. Okay, so this is the structure of NH3 and this is the structure of this carbanion. Okay, both the structures are having pyramidal shape and these are isoelectronic with each other. Now see their formation. The carbanion is obtained by the heterolysis. Heterolysis means uneven breaking of the bond. When the groups attached to carbon leaves behind the bonding pair in cleavage, usually this group will be proton because proton can leave the electron pair. Okay, so whenever you have given a group attached to a proton and there is a heterolytic cleavage of this bond, means to say this bond is breaking in this manner. Okay, means this hydrogen is moving without its sharing electron. Okay, actually this happens when you have given a base. See here, this is a base, this is a base. What will happen? This base will attack on this proton. Okay, so this bond will rupture and the electron pair will go on this R group. So we are getting a carbanion. Okay, we are getting a carbanion and this BH group is formed. In this way, a carbanion is formed. Generally, the proton is removed by the base when it is attached to electron withdrawing functional group like NO2 group. Because in general, this RH bond is not having much difference in the electronegativity of R and H. But if there is any functional group present that has the electron withdrawing tendency, okay, this R group is having suppose any COH group like NO2 group. So what will happen? These groups will attract or withdraw the electron density from the proton. So the proton can be easily removed by the base. Carbanions can also be formed when the nucleophile adds to alpha beta unsaturated compound. For example, suppose this is the nucleophile. This is attacking here. Okay. This is attacking here. What is happening? This is attacking here. This bond is moving in this manner. So you are getting a carbocation like this. Okay. Now see the stability of the carbanion. The stability of carbanion can be increased when the negative charge on carbon atom can be spread over a number of resonating structures. What is meaning of it? See here, this is the carbanion. This is having a pyramidal geometry in this manner. Okay. Now there is a negative charge on this. There is a negative charge. if we can decrease this negative charge, it means if this negative charge, it can be spread over these groups, it means it can be spread over here. Okay, this can be distributed between these bonds, or it can be spread over the resonating structures, then we can decrease this negative charge. Okay, and more we can decrease the negative charge means more we can increase the stability of the carbon ion. So if there is presence of any electron withdrawing group means which are having minus I effect. Minus I effect means like you have COOH group, like NO2 group, any of the minus I group. If it is present, then it will withdraw the electron density from this carbon atom, so it can stabilize the carbon ion by delocalizing the negative charge. Or there may be another condition. If there is the presence of a double bond or aromatic ring in conjugation with the carbon atom, then what will happen? There will be the conjugation. Okay, there is the conjugation means there will be the resonance of the negative charge. So this negative charge stabilizes by the resonance. So we can say there will be a opposite order that we have seen in the case of carbocation. There will be the opposite order of that. Means primary carbon ion will have higher stability, then secondary carbon ion, then the tertiary carbon ion. The relative order of stability of some anions is given in this following manner. Means phenyl group will be most stable because here the charge can be distributed over the ring, okay, aromatic ring. Then cyclopropyl anion, then methyl anion, then ethyl, then isopropyl, then isobutyl, and then cyclobutyl. This will be the order of stability. Now come to the reactions of carbon ions. First type of reaction is addition reaction. Carbon ions gives nucleophilic addition reaction with the carbonyl compounds and with the nitriles. Some of the reactions you have already studied. I have made the videos like aldol condensation, Claisen-Schmidt reaction, Michael reaction, Neff reaction, Diekmann condensation. These all are the example of nucleophilic addition reactions that are given by the carbon ion as intermediate. The second reaction is elimination reaction. Even CB reaction takes place via carbon ion formation as intermediate. See here what is happening. For example, CF3 CSCl2. This is treated with OR minus. This is a nucleophile. This is coming. So you are getting CF3 CCl2 minus. Okay. This is acting as a base and this is attracting the proton from here. You are getting CCl2 minus. Then again what is happening? This F will eliminate and you are getting CF2 double bond CCl2. So this is the carbon ion that is formed here. The third type is the substitution reaction. For example, alkylation of malonic ester, Woods reaction, Riemer-Tiemann reaction, haloform reactions. These all are the example of substitution reactions with the carbon ion as intermediate. Some of the rearrangements are also happening through the carbon ion as intermediate. Actually, this take place by 1-2 shift of the alkyl group or aryl group from the carbon to carbon, nitrogen to carbon, etc. This type of rearrangements are happening. Oxidation reactions can also be shown by carbon ions. Under suitable conditions, the carbon ion can be oxidized. For example, triphenyl methyl carbon ion is oxidized slowly by air. See here, this is PH3CH by Na. When you are treating it with sodium, you are getting PH3C minus. This is a carbon ion that you are getting, and this can be oxidized to give PH3C radical. Okay, so this is whole about the carbon ion. Okay, if you are liking my videos, then you can comment me, share these videos with other students, subscribe the channel, and if you want the full courses in detail, then you can visit our app. And if you want the free PDFs of these whole topics, then you can go to our channel, our Telegram channel. Okay, on Telegram channel you will get the free PDFs. Thank you.